you'll see where it says graphs of quadratic functions, and how you know it is a quadratic function is because it's going to have the first term will be like 2x squared or 3x squared or just x squared. You could have a trinomial like x squared plus 5x plus 6. You could have something like that. Or you could just have x squared. Okay, as long as the a term is x squared, we consider this a quadratic function. Okay, so what you're going to do is I would like you to go ahead and take your calculator. So let's go ahead to our calculators. All right. All right, so when I hit y equals, I'm going to type in x squared. And then when I hit graph, okay, you'll see a graph of what we call a parabola. So this is what we call a quadratic function, right? So you'll get used to seeing that because we're going to be talking about quadratic functions and different parts to that particular function. So let me close this out. All right, so going back to our note page, so that's what we call the parent function. So it's like the main function. So that's why we call it the parent function. And the graph of a function, of a quadratic function, is a parabola. So the name of it is called a parabola. Okay, I know it looks like parabola, but it's actually pronounced parabola. So to this parabola, and I'm just going to sketch it for right now. So this is what you sort of had on your calculators a few minutes ago. On this parabola, it has parts to it. So one part, or the main part, is the vertex. So this point that's right here where it dips, that's called the vertex. Okay, and and I'll show you how you can determine if the parabola is going downward in a few minutes. So if I ask you, just looking over here, what are the domains? That means I'm asking you for the x values. Well, of course, when we did that unit back in November, for parabolas, we said that, as this parabola continues to get bigger, the x values will obviously spread across the entire x-axis, and we put that in set builder. We said x such that x is an element of all real numbers. Okay, so we'll be revisiting that again, and you will have to make sure you know how to find the domain and range for these parabolas. Now, the good thing is, if the parabola is going up or down, this will never change for the x's. Okay, you'll have the same answer all the time, every single time. We can't say if it's going sideways, that's different. But if it's going up or down, the x values will continue to stretch across the entire x-axis. So that will be all reals. Now, for the ranges, you basically look and see where it starts at the y. In this case, this vertex point I'm going to call is 0, 0. So to get the range when it's going up or down, you look at the y value in the vertex. Okay, so this is the y value right here. So I'm going to say y value for range, and this is a big if it's going up or down. Okay, so if it's going up or down, you really just start at the y value for your vertex. In this case, it's 0. And then obviously the y's are getting bigger. So we say y such that y is greater than or equal to 0. So that's the same 0 that's right here. Okay, that's the y coordinate to the vertex. So that's your range. So if it were going downward, I would have said less than or equal to 0. Okay, because the y's would have been getting smaller. All right, that's the only difference. Okay. Okay. So go back to your calculators, and now I want you to put in, keep that one in, just go to the second row. So when you hit y equals, just go down to y sub 2, cursor down, and put in negative x squared. And then hit graph. So I want you to tell me what happened. Something happened on mine. So what happened to the parabola? It's not going up, it's going what? It's going downward. So simply by changing the a term, because you know when you're looking at a trinomial like this is the x squared term is called a. So if the a term, what can you conclude? If the a term is positive, the parabola will go up or down? Up. If the a term is negative, the parabola will go what? That's it. That's the conclusion. So really just looking at the squared term and knowing whether it's positive or negative, you'll know before you graph it whether it's going up or down. Okay, because if it's negative, it's going downward. All right. So let's move on to the second part here. This little fill in the blank in this second box. So there's a line that cuts the parabola right in half, and it has a name to it. All right, so let's say I just cut this parabola right in half. So if I cut it in half, I'm going to be going straight through the vertex because the vertex is in the middle of the parabola. So this line right here that divides the parabola into two mirror images, so that means makes it symmetric. That means one half looks like the other. Okay, that is called the axis of symmetry. Okay, axis of symmetry. So that axis of symmetry really, again, just divides that parabola right in half. Okay, that's what it does. It makes the left side look like the right side. Okay, that's called the axis of symmetry. Now, this axis of symmetry is a vertical line. Okay, so that means it's going to always start off with x equals to a constant. Okay, some number. Remember, vertical line equations just say like x equals 2, x equals 3, x equals -1. So in this case, this is x equals 0. Okay, but it's always going to be a vertical line, so it'll always start off with x. All right? All right. So now the lowest or highest point on a parabola is called the minimum or maximum value. And I'm just going to put min or max. So, or min or max points or min or max values, doesn't matter. So remember we just did when when the a term was negative and our parabola went this way, downward. So that simply means now the vertex is up here. It's like the highest point to our parabola when it's going downward. Is that a true statement? So that would be the maximum point when it is going downward. So I'm just going to put a down under the word max and an up under the word min, because when it's going upward, this is the lowest point, so that's your minimum point. Okay, and it makes sense. When it's going up like this is the lowest point of the parabola where the vertex is. When it's going downward this way, it's the highest point, so it's your maximum. It just makes perfect sense. Okay, it's all intuitive there. You know, max and min, depending if it's going up or down. So let's take a look at a couple things down here that we need to fill in the blank. Just put it on my desk. So here, right here, it says ax squared plus bx plus c, and you've seen that before in factoring. So that is what we call a quadratic function that is in standard form. Okay, so that's how we write this, our quadratic equations in standard form. You have your squared term, your x term, and then your constant. Now, you might not have all three, but you have to have this one. Okay, you got to have the first one in order for it to be a quadratic, because it has to be a square. Okay, it can't be a cube, can't be to the fourth power, it can only be to the second power. Okay, that's what we call a quadratic function. It may not have all three terms again, but it has to have the a term. It could have two terms. It could just have the a and the b. Whichever one it doesn't have, we assign the value of 0. Okay, just to let you know. All right, so really all of that is just a lot of vocabulary stuff so far. So let's go down to this first bullet here. So we already know the axis of symmetry just kind of cuts the parabola in half. You might want to circle this because that's going to be a very important formula you're going to use to find the axis of symmetry. Okay, remember I told you that the axis of symmetry is a vertical line. It will always say x equals. So, and this is how you're going to get the numbers to what that constant is. So, not only is it the axis of symmetry, it's also your x coordinate to your vertex. Now, how does that make sense? Well, let me let you see something here. So, okay, I'm going to erase what I have up here just so you can see it a little bit more clearly. So if I put this parabola up here again, and I'm, right here, and I know my vertex is here, my axis of symmetry is this line that cuts right through the vertex. So when it cuts through the vertex, it's going to also be the x coordinate to that vertex. And that's what it's saying in the second bullet. So if the axis of symmetry is cutting through the vertex, that means whatever x is also the x coordinate to the vertex. Because remember, when you do a vertex, you got to have an x and a y. So whatever this x is here, it's the same x that's going to go here. Okay, so that's what that second bullet is stating. Okay, the y-intercept. How do you find the y-intercept to a quadratic function? Well, if you're on the y-axis, what is the value of x? It's a good question. If you're on the y-axis, okay, right here, correct. The value of x will always be 0. If you're on the x-axis, what's the value of y? It's just the opposite, exactly. So when you're on this y-axis right here, the x-coordinate will always be 0. And to get what the y value is, it's going to be whatever the c term is. This number right here. And remember, I told you if it doesn't have all three, then what is that missing number? It's understood to be 0. Because you may not have all three, you might not have a c. Okay, and if that's the case, because I think actually on the next page, look, there's not a c. So that means c is 0. Okay, so if you don't have a c, that means c is 0, just to let you know. But that will be how you determine the y-intercept for the quadratic function. All right, so we already know this. The graph opens up, and you can say upward if you want. I just don't have enough space. If a is positive. Okay, we just saw that a few minutes ago on your calculators when you just put in like 1x squared. And then when you put in negative x squared, it went the other way. And it's down if a is what? Negative. And you just saw that on your calculator. Okay. All right, we don't need to fill in the last bullet. Let's go to the next page. So on this page here, page 4, it says for each quadratic function in standard form, do the following. We're going to identify the vertex and determine if that vertex is a maximum or a minimum point. We're going to identify the axis of symmetry, so I'll walk you through that. Determine what the y-intercept is, and then it says sketch the graph of the function and identify the domain and range. Okay, so that's a lot, but it's pretty easy to do. All right, so just looking at this a term, I'm not even going to put it on the calculator right now. I want you to be able to tell me. Since a is a positive 2, so I know this parabola will be going upward. Okay, so would this vertex be a minimum point or a maximum point? Minimum. Very good. I mean, you can do that without even putting it on the calculator. Okay, look at number 2. Since a is negative, so that's going to be going, downward. So now my vertex is going to be min or max? Max. Very good. Okay, and we'll do all the filling in the other stuff in a few minutes. Okay. All right, so let's do this. Determine whether the function is a min or max. Okay, positive. So what will this one be? Minimum. Okay, that'll be a minimum point. And over here, this will be a what for number 4? Maximum point. All right, so let's go ahead and determine how do we find out all of the other information. Now, I actually ask students to start with this one. I'm going to put a number 1 here just because this will be a good place to start, is by finding the axis of symmetry, because when you find the axis of symmetry, it's going to be the x coordinate to the vertex that I'm going to put up here. Okay, so once I have what x equals to here, then I can put it right here because those numbers are the same. Okay, so how do we find the axis of symmetry? Go back to this page here. Remember where I told you to circle? Right here. This is how you find the axis of symmetry. See where it says x equals the negative b divided by 2a. So that's what we're going to write. Negative b divided by 2a. And I already know a equals 2, b equals negative 8, and c equals 6 right here. Okay, a is 2, b is negative 8, c is 6. So now I know what all this a and b stuff would represent as a number. Right? So what is b? Negative 8. But what's a negative times a negative that's already in the problem? Positive. Okay, so we're going to write positive 8. Divided by 2 times, what is my value of a? 2. And we don't even need c in this particular formula. So everybody see that. We're only really using a and b. Now what I usually tell students when they see this negative b, just simply say to yourself, take the opposite sign of b. Because that's really what this negative is going to do, change this to its opposite sign. Now, if you want to write down a negative and then say later it equals to positive 8, that's totally up to you. I simply read it as what is the negative or what is the opposite side of b. And then I just write down positive 8 divided by 2 times 2. So what is 8 divided by 4? Okay. And that's the same 2 that's going to go here. That's also your x coordinate to your vertex. Because remember, this axis of symmetry is cutting the vertex right in half. So it has to be the same number. Okay. So when you have this number, you have the x coordinate to the vertex. Okay. Everybody okay with that? Do this 2 ways to find the y coordinate. I'm going to show you how to do it algebraically because you need to know how to do it algebraically. Okay. So since I know the value of x is 2, and this says y, and I'm trying to find y, and I know x, go to a blank screen on your calculator and simply put 2 parentheses, because now we're going to replace x with 2, square it according to my problem, minus 8 parentheses 2, and then plus 6. Okay. Now don't put this into the y equals. Okay, this is just on a blank screen on your calculator. 2 times 2 squared minus 8 times 2 plus 6. Anybody got the answer? How much? All right, so did everybody get negative 2? There's your other number to y. Okay, that's now you have a complete coordinate for your vertex. Okay, now let me show you another way you can do this. Okay, I'm going to show you another way. Go to your calculator and hit y equals. Okay, and now let's type in. So you're going to have to clear out these 2 here. Okay, clear those out. And go back to the first one and type in the problem. So 2x squared. Oh, I put 2 x's. Let me delete that. Okay. Plus, oh, it was a minus. All right, minus 8x plus 6. Okay. So now, if you do that, this is the other option. Hit second graph. We're going to go to the table. Uh-oh, I must have done something wrong. What did I put in? Let me see. Let's see. I shouldn't have any parentheses. Okay, let's see. All right, let me just type it in again. But you guys just go to your table and then go where x is 2 and see if it pairs up with -2. So you can get it off the table. All right. So you might have said, well, why do we take all that time to plug it in? Because you need to know how to do the math. Okay. So once I type it in correctly this time, hopefully, plus 6. All right, I'm going to go to the table. All right, and then see where x is 2. It pairs up with -2. Right? Now, for your homework, guys, I want you to understand, you may not always have integers. You know, it may not come out to be a nice 2. It might come out to be 3 over 2. So you might say, well, how am I going to do that on the calculator? Well, what's 3/2 as a decimal? Okay, divide it on your calculator and see. What is 3 divided by 2 on your calculators? I'll wait for someone to give an answer. Huh? 1.5. So let's say you get 1.5 for x. And you say, oh my goodness, I can't go to the table because the table doesn't have decimals. This is what you would do. And you're going to need to know this because there are a lot of decimals on the homework. They don't all come out to be these nice numbers. So if you don't want to do it by hand, like I just showed you, where you can just put it into the problem, see up here under above the word window, it says table set. That means you can set whatever value you want for x in the table. So everybody hit second window. So let's say x was not 2 like it was, and it was 1.5. So put in 1.5. And then the table will do it for you. So do second graph. It should be at the top of your table what the answer is. So that's how you can put decimals in the table. So when x doesn't come out to be a nice integer and it comes out to be a fraction, divide the fraction to see what the decimal is, hit second window, type it in, and then it'll be in your table. Okay, any questions on that? All right, so let's go back to our note sheet. Okay, so now we have the vertex is 2, -2. We know it's the minimum value of the vertex because it's going upward. We know the axis of symmetry is x equals to 2. Let's do the y-intercept. Remember I told you on the other page, the y-intercept is simply 0 something. How do we get the something? It's the c term. What is the c term in the problem? 6. That's it. Okay. You can always check it on your calculator. You can hit graph and see if it's going through the y-axis at 0, 6. Okay, let's do the domains. Okay, whenever a parabola is going upward or downward, the domains are always x, such that x is an element of all real numbers. That's going to be a standard answer for up and down. So I'm just going to go ahead and put it over here as well. Okay, that's the standard answer when it's going up or down. All right, now the ranges, I always refer back to the vertex. I'm going to put the vertex down here because the range number actually is it starts at the y coordinate of the vertex. Okay, and since it's going upward, it's just going to simply be y such that y is greater than or equal to -2. Okay, so you can look on your calculator, see it starts, the y's start at -2, and then since it's going upward, they just get larger. Okay, so always refer back to your vertex, and this is only when your parabolas are going up or down. Okay, I haven't done any sideways, just up or down for this rule. All right, let's go over here and do the axis of symmetry. Okay, so I'm going to erase some of this. All right, so the axis of symmetry, x equals the opposite of b over 2a. Okay, what is the opposite of my b term? Positive what? 6, okay, divided by 2 times the a term. So the a term is -3. So what is 2 times -3? -6. What's 6 divided by -6? All right. There's my axis of symmetry. X equals -1. It's also the vertex to the x coordinate. That's right, for my vertex. Okay. Satisfies 2 things. So now, punch it in your calculator. Go to your table and see what the y value is when x equals to 1. I'll let you do that. Okay, punch in, hit your y equals, put in -3x squared minus 6x, and tell me the y value when x equals -1. From last class. Okay, so the y coordinate should be 3. So check it in your table and make sure you got 3. Okay, all you do is just type this in, go to the table where x is -1, and see what the y value is. All right. Okay. All right, so let's do our y-intercept. 0 something. What is the something? There's no c term. So that means the c is what? 0. Remember I said if you're missing a term, then that means the value is 0. So we already had our domains, x such that x is an element of all reals. All right, now remember I said for the range you go back to your vertex point. So here's the y value right here, because ranges are y values. And since this is going downward, and my y's start at 3, so are they going to be getting bigger or smaller? Smaller. So y such that y is less than or equal to 3. All right, does that make sense? Okay. All right, now for this part down here, where you actually have to graph, this is what I'm going to ask you to do whenever you have to graph a parabola. Okay, so you'll make a t-table. You'll put the vertex in the middle and circle it. What was the vertex to the first one? 2, -2. All right, so we'll put the vertex in the middle and circle it. So this is all I'm going to ask you to do is to type, well, since we already have this one in already, go to your table. Okay, since you already have the second one already there. And then you're going to find this vertex point first in your table. So everybody do that. I'm not going to, you're not going to see it up here, so you got to follow it what I'm saying. So since you already have the second one typed in, or if you don't, type it in. Okay, find this point here, -1, 3. How many people have it? Okay, so now I want you to choose 2 points above the -1, 3, and I want 2 points below the -1, 3. So you can definitely choose any 2 points above and any 2 points below, but you want to make sure they're very small so they can fit. Okay, so go ahead and graph this. Okay, so -1, 3, we'll put as many as we can up here. So -1, +3. Okay, -2, 0. And let's do, you said 0, 0 was a point as well? Okay. All right, so we can probably use those 3 points and be able to make a parabola pretty much. Okay. As long as you have the points in the table and I can see what those points are, you can at least graph 3 out of the 5 that you have. You always have to graph the vertex, and you got to at least give me 1 point on the left of the vertex and 1 point on the right, and you can do all 5 to obviously make it more accurate if it'll fit. Okay, so just keep that in mind, so anytime you have to graph them. All right, so go ahead and fill in this table. and graph it, and then you'll be done with the notes for today.